these to the top. You can still see them a little bit to make your comparisons. I'm going to grab mineral sample 1 or rock sample 1. I can see that this looks like it's all one substance, and all of the surfaces look like they've been fractured. I don't see any crystal faces, maybe one every once in a while, but mainly it just looks fractured. What is this?
Quartz.
This is quartz. Number 1 is quartz.
What texture did you write?
It's not smooth. It's just quartz. I don't know what your sample looks like. Some of it can be super smooth. Mine is kind of bumpy because it's a fractured surface.
Yeah.
Okay, number 2 we've looked at as well. This is the pumice.
Aren't you supposed to be able to turn off the lights?
Number 3. Number 3 is a rock. And I see a few crystals in there, very few. But I do see crystal faces shining all through it. So I'm going to look at the back of my handout. I cannot identify the minerals just eyeballing this, but I can see that this rock is mostly dark. So I'm going to make an educated guess that this is an ultramafic rock. Maybe a mafic rock, because it's not totally black. This one is not coarse grain, it is fine grain. So the number 3 is basalt. Okay, obtain number 4. Sample number 4. Would somebody please, and when I say somebody, I mean the person that I picked their stick out of the cup. Tim, what do you observe about sample number 4?
That it is very light.
What do you mean light? What does that mean?
Color of it's not dark.
Okay, so it's light colored.
Light colored.
Okay, so that means we're going to be looking over on this left side of our chart.
I observed that there's some biotite muscovite.
Are you sure?
Maybe not your sample, but my sample with black specks.
Okay.
And there's lighter specks, and I don't think that they're quartz. And it's pretty fine grained, so I would call this rhyolite.
Okay, it's very fine grained, it's light color. Tim is going to call this rhyolite. Do we agree with Tim's assessment? I do.
I guess.
No, I really,
Yes.
but I didn't want to, nobody else can raise it.
No, I agree, Tim, that we'll call this rhyolite. Now, if the parent magma of this rhyolite were allowed to cool longer, if it didn't cool as quickly, what would it have been? What rock would it have been? Granite. Yes. Nice job, Tim. Number 5. Number 5 is a pink sample. Quentin, would you share your observations with me and the class about number 5?
I wrote for our sample was pinkish red. It looks like it's mainly one mineral with a couple of small specks of other minerals in there. It looked like a layered rock almost. Ours does at least. And
Okay,
then,
when you say layered, what do you mean?
like when I turn it on the side right here, it almost looks like it could break into layers.
Okay. All right. What looks like it could break into layers? What do you mean? Like, are there different colors? Or do you see fractures in
Different
there?
gradations.
Okay.
Yeah, along fractures. That works.
Okay, what did you call this?
It's feldspar.
This is feldspar. Yes, very nice. Number 5 is feldspar. Number 6 is very pretty. Number 6. Kim, what do you observe about sample number 6? That's not what I have in my hand.
If you grind it.
Okay.
Yeah, we have the green one.
You have a green one?
Everybody's is the same. Greenish.
What is your 6?
It really tells me it is. Feldspar.
Okay, everybody seems to have some different number 6s.
Could they be different colors?
They could be in different crystalline structures or different crystal sizes. Yeah, yours is like, she got number 6 again?
That's not 6, that's just 4. Oh, yours is way different.
Okay, let me give you a little hint. Number 6 is a mineral, and we did not see it yesterday. We did not see this yesterday. This mineral forms at very high temperatures and is found primarily in mafic rocks like basalt or gabbro or peridotite and comalite. This is olivine. Good job.
But where does it on the chart? Oh, so it's 45 to 85?
Yes, it's over here. It's the mineral olivine. It is not a rock, it's a mineral.
Right, but like my color of my sample, so is this not olivine then?
This is not an igneous rock, this is a mineral.
Olivine.
Yes,
But
this is the mineral olivine.
okay, but according to the chart, I wouldn't have put mine in the 45 to 85%
Because
rock color.
this is categorizing rocks, not minerals. This is the combination of minerals in the rock, and this is one of the minerals, and it can be much, much darker. Remember, the color is not always indicative of what the mineral is. This is one sample that happens to be a lighter green. Theirs is a darker color.
This is dark. It's gonna be over here.
Yeah, but you just said it doesn't.
Okay, number 7. Please get number 7. So Rochelle, this might help you. So this one, number 7, you can't see, this is not doing it any justice. Please observe number 7. Is this a rock or a mineral? This is a rock, okay? Now, because it's a rock, you can use this chart to determine what it is.
Oh, so when I was looking at the chart for the last one, it's not.
Right, right. Okay, so this chart tells us, first let's look at the color. Where does it go on the chart? Ultramafic, okay. So now, I've got it over here, so that I know that these minerals in here are probably olivine and pyroxene. It's very dark. Can I see coarse grained crystals in here? Can I see big crystals in here? Even though you may not be able to see the whole crystal surrounded, do you see big crystal faces? Then yes, it is coarse grain. This is peridotite.
Wait, what was it called again? Comeditite, the last one. No, so, under it. There's two eyes in it?
Crackers versus cracker crumbs.
I wrote this one.
Cracker crumbs versus cracker. Whole crackers. The whole cracker over it. So you make pieces that are coarse, like fine, so all of this.
All right, number nine is pretty simple. Y'all have seen this before. You call this volcanic glass or obsidian. Now, while this is considered a mineral, it's also listed on here because this obsidian forms from the whole magma. Like if you take a jar, like a sailol, if you take that sailol and you pull it very rapidly, it's going to turn into one big glass-like substance. So that is on here.
No, that's no.
I'm confused again.
Okay,
So obsidian, you just said mineral, it was not a rock. But I thought it was an extrusive
it is
rock.
extrusive.
An extrusive, so I thought that made that a rock. Like pumice is
Yes.
a rock,
Pumice is a rock.
but
So it
obsidian's
comes,
not a
so
rock.
obsidian forms very quickly, right? So imagine if you had the magma and it immediately hardened, this is what it would be. Okay? So that, but just, well, I'll get to that. So imagine if you take the solution that formed this, and you gave it just a little more time for different molecules to collect, like if you have carbon dioxide within here, right? Shh. You have carbon dioxide within here and you get a little more time, then there's, say, 50 carbon dioxide molecules that are going to collect together. Not enough time to escape, but they get trapped in there. So the carbon dioxide is removed, and then you end up with pumice, which is this, with gas bubbles in it.
Yeah, I'm kind of confused too. Okay, I just need to read and think about it.
That would become that. It's not a thing. Because it's one thing.
They add one more thing to it, to make it a mixture, and then
So changes
So the difference between a rock and a mineral, and this is kind of blurring that line. A rock is a combination of minerals.
yes, but I didn't realize that was a combination, I thought it was just temperature difference that made one pumice and one obsidian.
It
I didn't
is,
realize it
yeah.
was not just the temperature difference.
It's not just the temperature.
I thought it was
difference,
just the
it's
temperature
time.
difference.
Okay.
So.
Oh, that's beautiful. We'll have to show that. Thank you. Yes.
Just wanting clarification, if quartz is a mineral and it forms from the magma, is that
Yes.
correct? Then why is it not igneous? Or is
It
it
is.
igneous mineral?
It forms within an igneous rock.
Within an igneous rock?
Yes.
And then it gets broken out?
Yes, so as your granite is exposed to weathering, erosion, and deposition, those feldspars break down and become clays, and the quartz, which are very, very hard, they stay intact longer. That's why your beaches are made of sand, so all that stuff washes down, everything else is dissolved, and the quartz is left over. Yes.
Sorry, I think part of my confusion here is that it's on the igneous rock concept map.
Yes.
And so it comes down, and so I'm assuming if it's on this map, then it's a rock.
It is, because of all of the magma, so if you take all of the magma and harden it immediately, it ends up being obsidian. It is all one substance though. So
Yes.
obsidian is the result of that combination of magmas, all that chemistry hardens at one time. It's only one substance. So that one you say is a rock and a mineral at the same time.
Kind of like your silicates are also off your
Yeah, yes,
quartz.
Right.
Okay, so
Right.
it's actually both.
yes.
Okay.
And that is an exception to that rule. Now, at given time, if you took that same solution and cooled it much slower, then the obsidian wouldn't form and you would get larger crystals of different minerals.
And that's definitely wrong.
Yes,
Okay, so
yes.
this is the only one where there's that funny
Yes.
little, okay.
I'm gonna skip ahead, we're short on time, and I have something I want to show you. Number 13. If you look at number 13, on your color scale, it's gonna go into the mafic category, because it's mostly dark, not totally dark. It is more crystal, it's more, you can see all the crystal faces. This is a gabbro. If you take number 3, please listen. If you take number 3 and compare it to number 13, this is made up of the same stuff, guys. One is just more crystalline than the other. Basalt is microcrystalline or fine grain, whereas gabbro is more coarse grain. It's the grain size that distinguishes them. Can I use those?
It's same as, what
If
was
you can
three?
see crystals?
What, Laura, what was the other rock?
Gabbro?
No, it was
Basalt.
basalt.
All right, so Kim, Pam, Toby, and Brandon have their samples ready. And we're gonna go over this, we're gonna look at this and answer some quick questions and be done, okay? We're not gonna finish this investigation like we wanted. Which one of these, do you think this was the cold petri dish, the room temperature dish, or the hot dish? This is the cold dish. Look how fine those crystals are. It cooled quickly, theoretically. This one, well, let's look at the other extreme. Do you see the huge crystals in here? Hot,
Long lines.
cold, or room temperature? Hot. Because that petri dish was hotter, the solution did not cool as quickly, and so the crystals had time to form. The middle one, like the 3 bears, was just right. And these crystals are intermediate between the cold petri dish and the hot petri dish. And you can see the grain size increases with the cooling time. So if these were representative, listen please, if these were representative of cooling environments, which one of these would best represent an intrusive rock? Point. Which one of these would best represent an extrusive rock? Okay? So when you go out to the hill country and you go to an enchanted rock, and you see the granite, and you see those beautiful crystals in the granite. Is that an intrusive rock or an extrusive rock? Intrusive rock, okay? When you go to Hawaii, field trip, and you see the hardened lava, whatever form it may take, and you don't see any crystals in this lava rock. Is that an intrusive rock or an extrusive rock? Extrusive. Extrusive, okay. Any questions?
14.
14.
Come on.
That's what I thought. I just make sure.
I don't even see a 14.
I have a 14.
Oh, number 14, I was looking for question 14.
That's what I thought.
Okay, question 14. Rock or mineral?
Mineral.
Mineral. You saw it yesterday. This one's hornblende.
What? No.
It should, this one,
No, this one is
take longer than this one. Something was wrong with your solution.
You remember what I asked you this morning about, are you gonna mess this up again today?
Yeah,
Wait.
this
And this one,
this one
Hornblende's on my
looks
list.
more like agate.
that
Yeah,
was
it's okay.
Yeah.
Our 14 is okay.
It's either agate or hornblende.
So what's the coma? What's your 14?
Number 10 should have been agate. Oh, I'm sorry. Number 14, I'm so sorry. I grabbed the wrong one. 14 is on my key it says hornblende. And number 10 should be agate, but I can't find it. Here it is.
11.
I can't tell from my sample though.
So which one is the coma light or however you say that one?
The what one?
Oh, is it comatite?
It's not in the box. We don't have that one.
What was 11?
So that's.
I think you said 9 was. I think that would
Yeah.
Number 11
That's different
was
than what
diorite.
diet.
Diorite, yes.
I think you're right.
All right, ladies and gentlemen,
Bigger.
we're gonna stop and clean up. Material or maintenance director, bring your rock boxes back over here. Bring your, please listen, your Ceylon Petri dishes. If you're still observing, you can leave them there. But they need to be cleaned up before you come back from lunch. So all the supplies you can bring over here and organize.